Before talking about the mode 2 programming, let's just review about mode 1 programming. So in mode 1 programming, in any timer we know that the frequency or the clock available for the timer to advance the timer or the for making the timer to count up is crystal frequency divided by 12. So that is the frequency that is available for the timer to start counting from the initially loaded value to FFFF. Okay, so in the case of mode 1, you have this frequency coming here. You have an AND gate, and one of the inputs to the AND gate is TR. So you'll make TR equal to 1 when you want the timer to count up using the instruction set B TR0 or TR1 depending on which timer you are using. So then you'll load the value into TH and TL. So that will be done first. You'll then make TR equal to 1 so that from the initially loaded value it will start to count up to the maximum value, and one more clock pulse will make it equal to 0. So FFFF to 0000 will make TF equal to 1. So when TF is equal to 1, that is an indicator. It will make TR equal to 0, and if you want to continue the count, you will reload TH and TL with the initial value, and this will continue. So that is mode 1 counter. Sorry, mode 1 programming. Now coming to mode 2 programming, this is the setup for mode 2 programming. So again, the timer frequency is 1 by 12th of the crystal oscillator frequency. Again, you have an AND gate. TR should be made equal to 1 using the instruction set B TR0 or TR1 so that the frequency will reach the timer, making it to count up. So here the difference is that in the other case, TH and TL were loaded values which can be different, but in the case of mode 2 programming, the TL and TH value are copies of each other. And here also this TL value, it will count, since TL is just 8-bit register, it will count up to FF, and after counting up to FF, it will go to 00. So that will make TF equal to 1. In the earlier case, it was FFFF of TH and TL going to 0000 of TH and TL. In this case, it is only TL that it's checking. TL will go from FF to 00. That will make TF equal to 1. And TF is equal to 1. Again, the same thing. But only difference is that in the case of mode 1 programming, you have to reload the timer with the value with an instruction. That is, you'll be going back to that particular instruction where you loaded the initial value. But in the case of mode 2 counter, the setup is such that it will reload by itself. Automatic reload is what is happening in the case of mode 2 counter. So let's come to the characteristics of mode 2 counter. Having seen the setup, so it's an 8-bit timer as we already know. It will count from 00 to FF. After TH is loaded with the 8-bit value, the copy is given to TL. Okay, so TH and TL will have the same value. In the case of mode 1 programming, TH and TL had different values. It can have different values. So after loading the 8-bit value to TH and TL getting the copy of it, the timer must be started with the instruction set B TR0 or set B TR1. After starting the timer, it will start to count up, incrementing the TL register, and it counts up until it reaches FF. Then it goes to 0, 0, making the timer flag equal to 1. So when timer flag equal to 1, TL is reloaded with the value where from TH, because TH had a copy of whatever value TL had. So that value will be kept as a backup. The TH will have the value kept as a backup so as to reload TL when TF is equal to 1. And this process is repeated. For that, only clear TF. So mode 2 is an auto reload. That's why it's called an auto reload, in contrast with mode 1, in which the programmer has to reload TH and TL values. So that is the difference between mode 1 and mode 2. Now again, in mode 1, we had a set of procedures or algorithm to generate a time delay. Likewise, you have a similar one for mode 2 also. So again, just like there, you have to load a T mode value with the mode of programming. In the earlier case, it was 0, 1 for the particular timer. Now it is 1, 0. So the timer, you can choose whichever timer gets the mode value 1, 0, that timer will be working. And load the TH registers with the initial count value. A copy of it will go to TL. Start the timer. Keep monitoring the TF flag with jump if no bit TF0 or TF1, just like in the earlier case. And that will continue. That loop will continue until the TF is equal to 1. When TF is equal to 1, it will come out of the loop, clearing the TF flag. And it will go back to the go back to step 4. That is, in the earlier case, it will go back to the position, to the instruction where it was going to reload the initial value. But in this case, we are just going back to the instruction where the TF or the timer flag is monitored. So that is the difference between mode 1 and mode 2 programming. So here we have an example. Crystal frequency is like always 11.0592. Frequency, find the frequency of the square wave generated on pin 10 in the following program. So a program is given to you, crystal frequency is given. We want the square wave frequency. So T mode has the value 20. 20 means 0010 0000. So it is timer 1 mode 2. Then TH1 has a value 5. So TH1 is loaded with the initial value we know. So whatever value comes to TH1 in this particular arrangement, that value will go to TL1 also. We needn't write it as such. It will go because of the internal connection. Then set B TR1 so that the timer is started. So from where will the timer start to count? From the value 5. So 5, 6, 7 like that it will count up to FF. So when it goes from FF to 0, 0, what happens? The TF flag is, TF1 flag in this case is set to 1. So until then this particular loop, that is jump if no bit TF1 back, this particular instruction will be executed until TF1 is equal to 1. Until that change happens, high to low change. After that, it will come out of the loop. So our program was to complement or generate a square wave. Square wave means what? 1010 likewise. So that's why we are complementing P10. Then clear the TF, that is one sequence is over, so you have to clear the TF1 flag and jump back. So where are we jumping to? Like we already discussed in the algorithm, we are not jumping back to reload the value of TH or TL. We are jumping back to only analyzing the value of TF1. So in the earlier case, we would have to jump to this move th1 comma #5. But in this case, since it's an auto reload mode, since the internal connection is such that it will be auto reloaded, you needn't write an instruction to reload it. You are just going to analyze the TF1. So that is the difference between the two modes of operation with respect to a program. So now what do you want? You want to find the frequency of the square wave. So how do you find the frequency of the square wave? You'll have to know the final value. You need to know the initial value in the register TH or TL. Then that will be multiplied with 1.085 and you'll get a value that is one portion, one half of the pulse multiply by 2, that will give the total time period. 1 by the time period will give you the frequency. So in this particular case, we have written it in decimal itself. So FF is 256 minus 0.5 into 0.085 microsecond. So you'll get 272.33 in the high portion of the pulse, and for the total period you'll multiply it with 2. So you have the total time period, and 1 by the time period will give you the frequency. Again, find the frequency of the square wave generated on P10. So here the TH value is 0, T mode is 2H. 2H means it is 0, 2H. So 0, 2 means timer 0 has the value. So timer 0 mode 2. TH0 is loaded with the value 0, so it will count from 0 to FF. So move R5, 250. It's a delay count. Then it's calling a delay. So this is the delay program. So set P TR0. Why? To start the timer. So the timer will start to run, and it will start to run from where? 0 to FF. So after it reaches FF, one more pulse, it will go to 0, 0. TF will be set to 1. Until then, it will remain at the loop back. After getting that 1 to 0 transition, it will clear the TR0 and TF0. And after clearing these, it will go to, it will check the value of R5, and if R5 is not equal to 0, go to delay. So this delay program will be executed how many times? It will be executed 250 times. So here you have a delay. That delay program will be executed 250 times. So R5 is a counter which will make the delay program to be executed 250 times. Then it will return. Return to where? Return to this position, so that it will jump to this position. Okay. So what is the time delay? It is once the delay is executed how many times? 256 minus 0 into 1.085 microsecond. That is for 1/2 of the time period. That multiplied by 2 will give the one full period for one delay. Likewise, you have 250 times that delay executed. So that multiplied by 250. So this is the total time and the frequency will be 72 hertz. I have a question. Assuming that we are programming the timers for mode 2, find the value in X, load into TH. If the instruction is move TH1 comma hash minus 200. Okay, so minus 200, it is a negative value. So let's see how this is done. We want the value in hex that is moved to th1 if you give such a value. So we know that since h is not written, this is a decimal value and also it's given as a negative value. So first of all you have to find the equivalent hex of this minus 200. So minus 200 means to convert it to hex, we'll have to first convert it to binary. Then from the binary, that is 200 has to be converted to binary. So this is minus 200. You will first do what? Binary of 200 you will find. Then you'll find the 2's complement of minus 200. Then that value you will convert to hex. Okay. So minus 200. So first convert to binary. So how do you convert decimal 200 to binary? So for that 200 you will divide it with 2. So you have 100. Remainder will be 0. Again 1 divided with 2. So remainder is 0. Then 100 divided by 2 will be 50. Again remainder is 0. So that is again divided by 2. 25. Remainder is 0. Again 25 is divided by 2. is 1. So 12 is again divided by 2. So that will be 6. The remainder will be 0. Again 6 is divided by 2. That will be 3. And the remainder will be 0. Again 3 is divided by 2. So that will be 1 and a remainder will be 1. So 200, the answer will be from down to up. So that will be 1 1 0 0 1 0 0 0. So that is 200 to binary. So 200 to binary will be this. So next you have to find the ones complement of minus 200. So that will be, you have to put, so this is 200. So in order to find ones and twos, you have to add a sign bit. So this will be 1 0 0 1 1. That will be 0 1 1 1 plus 1 will give you the 2's complement. So the 2's complement of minus 200 is equal to, so that is, here you have a sign bit 0 0 1 1, then you'll have 1 0 0 0. You can just add and see. Okay, since it's difficult to write from right to left in a computer, I'm writing it from left to right. So it is 0 carry over 0 carry over, so 0 1, then 1 1 0 0, and this is the sign bit. So you don't need the sign bit here. So in hex it will be 3. That is hex of minus 200. So that is how you compute the value that is loaded to TH if it's a negative number.